Hi, my name is Morgan Cupp, and in this video I'll be demonstrating my final project for ECE 3140. For my project, I created an LED pattern generator. To use this, you first plug it in and it will display a welcome animation. Once this animation ends, you can select two modes. One of the modes is called freestyle mode. In freestyle mode, you can press any LEDs you want for however long you want, and it'll display that output. The other mode is called repetition mode. In repetition mode, you can input any sequence of LEDs and it'll play that back to you. So first you get a countdown telling you when to start. Once the countdown is over, press any LEDs you want, and once you're satisfied with your input, press this button. From there, it'll play back to you, and you can speed it up, slow it down, and reverse it. Everything in this project is powered via USB. You can also see that everything on the breadboard gets power from the 3.3 volt and ground pins of the microcontroller. When you press a button, it connects to 3.3 volts, meaning that the I/O pin configured as input will read a 1. Similarly, when the button is not pressed, it reads a 0 because it's connected to ground and due to the internal pull-down resistor I've enabled in every input pin. For the LEDs, they're all configured as GPIO outputs, and so when you write a 1 to the output pin, the LED will see a 3.3 volts here, causing current to flow, and it'll light up. Every LED is connected in series with a resistor, that's so that the LEDs don't burn out. It's important to note that the white and blue LEDs require more power, and so they have a lower resistor. Also important to note is that although my arrangement of the board shows that, for example, this button is associated with this LED, these are not related in hardware, they're only related in software. Furthermore, this 6th button does not map to any LED that has additional functions, which you'll see. The first thing that software does when you first start the program is it'll call initialization functions. These functions will configure the push buttons as inputs and the LEDs as outputs. The next thing that happens is you get a welcome animation, and you can see it right here. This animation I created along with all of the LEDs turning on and off. That all occurs through LED on-off helper functions. The next function you get to is called mode select. Mode select lights these two LEDs, and what it does is using polling, it checks whether you press this button or this button. If you press the yellow button, you enter freestyle mode, calling function freestyle, and as I showed, that just means you can press any buttons you want, any order, however long, and it'll show the pattern. And to get out of this mode, you just press reset, calling the welcome animation again. To enter repetition mode, press the blue button. When you press this button, you call pattern input, and that first displays this countdown animation. Once the countdown is over, you can input any sequence of LEDs like so. Once you're satisfied with your input, you can press the non-LED button right here, and this says that you're done with your input and satisfied. Button presses and releases are detected using polling. Every button press or release is stored as an LED action struct. Every LED action struct identifies a specific LED, whether it was turned on or off, and the elapsed time since the previous LED action struct was created. This time is calculated using a real-time clock like in Lab 5. You're limited to 45 button presses due to memory constraints. Furthermore, all of the LED action structs are stored in a circular, doubly linked list. The function you're seeing here is called modify, and this tells users that they can press this button to speed up their sequence, this button to slow it down, and this button to reverse it. So press this button to call display. When you call display, your pattern is played back to you as mentioned. You can press the red button to speed it up as fast as you want, the green will slow it down, and then white will reverse it. You can call reverse as many times as you want. This display is created by iterating through the circularly linked list. To change the speed of the pattern, the delay field of every LED action struct must be modified. To change the direction of iteration, the interrupt service routine changes variable direction. This will cause the iteration to occur in the opposite direction. Implementing this reversal was especially challenging because I found that in order to reproduce the user's input in reverse, not only do you have to change the action field of every LED action struct, but you also have to do the delaying and LED actions in reverse order when you're iterating the list in reverse. It was also hard to detect button presses and releases during polling, which corresponds to a rising and falling edge. And so what I ended up doing is having two variables for every button, one for the current value and one for the previous value, and every iteration of the while loop you compare these to detect a rising or falling edge. I also had a lot of issues miscounting button presses due to button bouncing, and I eventually resolved this in software by implementing a millisecond delay after every detected button press so that the button had time to settle out prior to the next polling cycle.